In this video, we're going to begin our discussion of allylic and benzylic systems. So this is pulling together information from a few different chapters. Here we're going to talk about a little bit of general information, and then in subsequent videos, we're going to talk about reactions and reactive species, focusing on carbocations, anions, and radicals. Now, when we talk about the allyl group, this refers to an alkene and then the adjacent carbon. Okay, so this entire group is an allyl group. So this can be used as a name, so that here is our allyl group, and this is an alcohol, so this would be called allyl alcohol. And over here, this is our allyl group, and then this is a chloride, so this would be called allyl chloride. In addition, we have the benzyl group. So the benzyl group involves benzene plus the neighboring carbon. All right, so this whole thing is the benzyl group. And again, this can be used as a name. So here is our benzyl group, and this is an alcohol. So this compound is called benzyl alcohol. And here is the benzyl group. It's a bromide. So this compound is named benzyl bromide. Okay, so it's important to be able to recognize an allyl group as well as a benzyl group. Now, in contrast to a benzyl group, I wanted to remind you that this, as a substituent, is a phenyl group. So this would be phenyl bromide as opposed to this as benzyl bromide. In addition to allyl compounds or benzyl compounds, we also often need to think about the allylic or benzylic position. So whenever we're talking about an alkene, the carbon next to it, this is the allylic position. So this is referred to as the allylic carbon, and whatever is connected here, these would be allylic hydrogens or allylic whatever. Another group that's important to consider is the benzylic position. So this is our benzene ring, and so what's adjacent to it is called the benzylic position. So this is the benzylic carbon, and then we might have connected to it benzylic hydrogens or a benzylic alcohol or whatever it is that is connected here. So the term allylic and benzylic can also be used as a descriptor. So this compound, it's not just allyl alcohol, right? Because allyl alcohol would have the alkene and then a CH2OH, but this has something else connected to it as well. But we can use allylic as a descriptor because this is the allylic position and connected to it is an alcohol. So this could be referred to as an allylic alcohol. And the reason why we want to be able to identify allylic positions and benzylic positions is because they have special reactivity. And that's what we're going to be looking at in the next couple of videos. So this is called an allylic alcohol, but its name is different. So 1, 2, 3, 4, 5. This is, it could be named pent 1-ene 3 all. All right, but just looking at the name, it's not obvious what's special about this compound. So using the descriptor of an allylic alcohol, that can be helpful. If we look at the next compound, we're still talking about an allylic system. Remember, just having a double bond in a six-membered ring does not make it an aromatic. Okay, that does not make it benzene. Benzene has to have the six-membered ring with alternating double bond, single bond all the way around. This is just an alkene that happens to be in a six-membered ring. So then we're looking at this as our alkene, and therefore this is an allylic position, and this is an allylic position. So here is an allylic position, and here is an allylic position. at the bottom one, this is only connected to hydrogens, but at the top one, we have a bromide connected there. So this compound can be referred to as an allylic bromide. And then finally, the third compound, we have benzene, and then this is the benzylic position, and we have an alcohol at the benzylic position, so this can be called a benzylic alcohol. So here we just have some general information about the allylic and benzylic positions, and what we're going to see is that having an alcohol at the allylic position, it's going to behave differently than if we had the alcohol at this position or connected to any other sp3 hybridized carbon, right? So remember, our functional group is not connected to one of the alkene carbons, right? This is not a vinylic substituent, it is an allylic substituent. And having a functional group at the allylic position, that's going to have some special reactivity. The same thing is true with a functional group at the benzylic position. Having the alcohol here makes it react differently than having the alcohol here, or connected to any other sp3 hybridized carbon. So in the next videos, we're going to see some examples of the special reactivity of functional groups in allylic or benzylic positions.